Beyond Neptune, the frozen realms of the outer solar system. Beyond the orbit of Neptune, 30 astronomical units from the Sun, our solar system does not end. It continues far into the darkness. Here, in the outer reaches of our cosmic neighborhood, lies a realm of frozen worlds, ancient, pristine, and largely unexplored. A vast donut of ice and rock that holds secrets from the very dawn of our solar system, preserved for over 4.5 billion years in a cosmic deep freeze. This is the Kuiper Belt, and beyond it lie even stranger, more distant realms. Tonight, we journey to the frozen edge of the Sun's dominion. We'll explore the icy worlds that drift in eternal twilight, meet the spacecraft that dared to venture this far, and discover what these frozen relics tell us about how our solar system, and perhaps we ourselves, came to be. This is the story of what lies beyond Neptune. Act 1. The Edge of the Known. The Last Giant. Neptune marks the boundary, the eighth and final planet, orbiting at an average distance of 30 astronomical units from the Sun, 30 times farther than Earth. At this distance, sunlight is 900 times fainter than on Earth. The Sun itself appears as little more than a bright star in Neptune's sky. For most of human history, Neptune was the frontier, the edge of the known solar system. But in 1992, everything changed. The discovery that changed everything. On August 30th, 1992, astronomers David Jewett and Jane Liu, using the University of Hawaii's telescope on Mauna Kea, detected a faint point of light moving slowly against the background stars. The object was designated 1992 QB1, later named Albion. It was small, perhaps 160 kilometers across, and orbiting at 44 astronomical units from the Sun, far beyond Neptune. Albion was the first confirmed Kuiper Belt object ever discovered, excluding Pluto. For decades, theorists had predicted such a population of icy bodies beyond Neptune. In 1951, astronomer Gerard Kuiper suggested that during the solar system's formation, not all material coalesced into planets. Some remained, frozen in time, orbiting in a distant belt of debris. The discovery of Albion confirmed it. The Kuiper Belt was real. In the 3 decades since, astronomers have cataloged over 1,000 objects in this region, and with every discovery, the solar system's outer limits have expanded. Understanding the architecture. The Kuiper Belt is not a single uniform structure. It is a complex region with distinct populations, each with its own story. The classical Kuiper Belt extends from roughly 42 to 48 astronomical units from the Sun. Here reside the cold classical objects, worlds in nearly circular orbits, undisturbed since their formation. Arrokoth, the snowman-shaped object visited by New Horizons in 2019, is one such world, a pristine remnant of planetary formation, unchanged for billions of years. Then there are the resonant populations. The most famous are the Plutinos, objects, including Pluto itself, locked in a 2 to 3 orbital resonance with Neptune. For every 3 orbits Neptune completes, these objects complete exactly 2. This gravitational dance has stabilized their orbits for eons. Beyond the classical belt lies the scattered disk, objects with highly elliptical orbits flung outward by gravitational encounters with Neptune billions of years ago. Eris, the dwarf planet, whose discovery demoted Pluto, belongs to this scattered population. And then there are the truly distant ones, the sednoids, objects so far that Neptune's gravity barely touches them at all. Act 2. Pluto, the first revelation. The world we thought we knew. For 75 years after its discovery in 1930, Pluto remained mystery. Even the Hubble telescope could barely resolve it, just a fuzzy pixelated blob showing hints of light in dark regions. We knew Pluto had a moon, Charon, discovered in 1978. We knew it had a thin atmosphere of nitrogen, but what Pluto truly looked like, what its surface contained, remained unknown. Until July 14, 2015. New Horizons, humanity's first visit. At 1:11:49 UTC, NASA's New Horizons spacecraft, traveling at over 50,000 kilometers per hour, screamed past Pluto at a distance of just 12,500 kilometers above its surface. The images that followed stunned the world. Pluto was not the dead, cratered ice ball scientists expected. It was geologically alive. The spacecraft revealed a world of extraordinary complexity. A vast, heart-shaped nitrogen glacier named Sputnik Planitia, about 1,000 kilometers wide, dominates the surface, undoubtedly the largest known glacier in the solar system. This glacier is young, perhaps only 10 million years old in a solar system 4.6 billion years old. Its surface is divided into strange polygonal cells, each tens of kilometers across. These are convection cells, warm nitrogen ice rising from below, spreading, cooling, and sinking at the edges in a slow churning motion, like a lava lamp frozen in cosmic time. Mountains of water ice rise to heights of 3,500 meters. At Pluto's frigid temperature of -229 degrees Celsius, water ice is as hard and strong as bedrock on Earth. New Horizons measured Pluto's thin nitrogen atmosphere extending as far as 1,600 kilometers from the surface, with up to 20 observed atmospheric haze layers, possibly induced by pressure waves driven by airflow over Pluto's mountains. The atmosphere itself is blue, a delicate azure glow when seen backlit by the sun, caused by tiny haze particles scattering sunlight. Perhaps most remarkably, nitrogen ices in Pluto's heart go through a daily cycle, subliming from ice to vapor in daytime sunlight and condensing back during the frigid night, driving nitrogen winds that circulate around the planet at up to 20 miles per hour. Pluto's heart actually controls its atmosphere and climate. Charon in the small moons. Pluto is not alone. Its largest moon, Charon, revealed mysteries of its own. Charon is massive, about half Pluto's diameter. Together, they form a binary system, orbiting a common point in space between them. New Horizons found a belt of jagged mountains and canyons slicing across Charon's equator, evidence that long ago the moon might have harbored an internal ocean of liquid water that later froze, causing the surface to crack and buckle. Charon's North Pole is painted with reddish material, complex organic molecules produced from gas escaping Pluto's atmosphere that was caught by Charon's gravity and broken down by solar radiation. Pluto's 4 smaller moons, Styx, Nix, Erebos, and Hydra, are spinning chaotically, tumbling through space in complex gravitational dances unique in the solar system. Act 3. Arrokoth, a message from the beginning. The most distant encounter. After its Pluto encounter, New Horizons continued outward. Its mission was not over. On January 1, 2019, at 12:33 a.m. Eastern Time, the spacecraft flew past a small Kuiper Belt object 6.6 billion kilometers from the Sun, 4 billion miles farther than Pluto.
This object, later named Arrokoth, a Native American word meaning sky, became the most distant object ever explored by a spacecraft. And it was unlike anything we'd seen before. The Cosmic Snowman. Arrokoth is a contact binary, 2 distinct lobes gently touching, resembling a cosmic snowman lying on its side. End to end, Arrokoth measures about 35 kilometers long, 20 kilometers wide, and 10 kilometers thick. The larger lobe is flattened like 2 lenses placed back to back. But the most remarkable thing about Arrokoth is not its shape, it's what that shape tells us. The two lobes are just touching each other, as if they are kissing, or if they were spacecraft, they would be docking. There is no evidence that the merger was violent at all. Scientists analyzing the data concluded that the two lobes came together at speeds of less than 3 meters per second, walking speed, perhaps even slower at less than 1 meter per second. This gentle merger is revolutionary. It suggests that Kuiper Belt objects did not form through violent collisions as asteroids did in the inner solar system. Instead, they formed through gravitational collapse, clouds of small icy particles slowly gathering together under their own gravity. Arrokoth is primordial, unchanged since its formation 4.6 billion years ago, a fossil from the very beginning. Cold classical Kuiper Belt objects like Arrokoth occupy a narrow region about 6 astronomical units wide, between 42 and 48 astronomical units from the Sun. They are called classical because they are on the sorts of orbits that Kuiper talked about and appear to be the gravitationally unperturbed and original material of the Kuiper Belt. Act 4. The Dwarf Planets of the Deep. Eris, the world that redefined a planet. In 2005, astronomers discovered an object in the scattered disk that would change the solar system forever. Eris is the most massive and second largest known dwarf planet in the solar system, measuring 2,326 kilometers in diameter. Its mass is 27% greater than Pluto's, although Pluto is slightly larger by volume. Eris orbits in a highly elliptical path that takes it from 38 to 98 astronomical units from the Sun over the course of 557 years. Its discovery forced astronomers to confront a question they'd been avoiding. What exactly is a planet? The debate led to the historic 2006 decision by the International Astronomical Union to create a new category, dwarf planets. Pluto was reclassified, joining Eris in this new designation. Eris has a small moon, Dysnomia, and its surface is covered with methane ice. The dwarf planet is so distant that its surface temperature barely reaches -231 degrees Celsius. Haumea, the spinning football. Haumea is one of the strangest objects in the Kuiper Belt. Roughly the same size as Pluto, Haumea is stretched into an elongated shape, like a spinning football made of rock and ice. It rotates once every 4 hours, one of the fastest rotation rates of any large object in the solar system. This rapid spin has pulled Haumea into an oblong shape with dimensions of roughly 2,000 by 1,500 by 1,000 kilometers. Even more remarkably, Haumea has a ring, discovered in 2017 when the dwarf planet passed in front of a distant star. This makes Haumea one of only 2 trans-Neptunian objects known to have rings. Scientists believe Haumea's strange properties result from a massive collision in its distant past, an impact so violent that sent fragments spinning off into space. Several other Kuiper Belt objects share similar orbits and compositions, suggesting they may be pieces of Haumea blasted away in that ancient collision. Makemake and Quawar, worlds awaiting exploration. Makemake, discovered in 2005, is the 3rd largest known Kuiper Belt object. About 2/3 the size of Pluto, Makemake has a surface covered in methane ice that gives it a bright white appearance. Recent observations revealed that Makemake, like Haumea, has a small moon nicknamed MK2. This discovery allows scientists to calculate Makemake's mass and density, revealing it to be slightly less dense than Pluto. Quawar, discovered in 2002, is another large Kuiper Belt dwarf planet. Like Haumea, Quawar possesses a ring system, discovered in 2023. This ring orbits at a distance far beyond what theoretical models predicted was possible, challenging our understanding of how rings can remain stable. These worlds remain distant and mysterious. No spacecraft has visited them. Everything we know comes from telescopic observations, glimpses of reflected sunlight from worlds over 40 times farther from the Sun than Earth. Gonggong and Sedna, worlds of deep red. Gong is a scattered disk dwarf planet about 1,230 kilometers in diameter, discovered in 2007. It has one of the reddest surfaces in the solar system, likely covered with organic compounds called tholins, complex molecules formed when methane ice is bombarded by cosmic radiation. But perhaps the most enigmatic dwarf planet in the outer solar system is Sedna. Act 5. Sedna and the Inner Oort Cloud. The loneliest world. Discovered in 2003, Sedna occupies a realm beyond the Kuiper Belt, a region so distant, so isolated, that it may represent something entirely new, the inner edge of the Oort cloud. Sedna takes approximately 11,400 years to complete one orbit around the Sun. Its orbit is one of the widest known in the solar system. At perihelion, its closest approach to the Sun, Sedna comes within 76 astronomical units. At aphelion, it travels to an astounding 937 astronomical units, nearly 1,000 times Earth's distance from the Sun. Currently, Sedna is about 86 astronomical units from the Sun, slowly making its way outward on its millennium-long journey. Sedna is almost as red as Mars. Its deep red color is caused by an extensive surface coating of hydrocarbon sludge, termed tholins. These organic molecules give Sedna its distinctive crimson hue. What makes Sedna truly mysterious is how it got there. Neptune's gravity cannot have placed Sedna in such a distant orbit. The giant planet's influence doesn't extend that far. Something else must have shaped Sedna's path. Several theories exist. Perhaps Sedna was pulled into its current orbit by a passing star when the Sun was still young, part of a crowded stellar nursery. Or maybe a distant, undiscovered planet, sometimes called Planet 9, gravitationally shepherded Sedna outward. Sedna is likely not alone. Simulations suggest about 40 Sedna-sized objects probably exist in this region. The growing family of sednoids. Beyond Sedna, astronomers have found 3 more objects in similar orbits, collectively called sednoids. In 2014, astronomers discovered 2012 VP113, an object about half Sedna's size, with a perihelion of 80 astronomical units. In 2025, astronomers discovered 2023 QA14, now nicknamed Ammonite, a Kuiper Belt object with a highly unique orbit. Computer simulations determined that Ammonite has followed a stable orbit for at least 4.5 billion years, dating back to the solar system's earliest times. What makes these sednoids fascinating is their perihelia, their closest approach to the Sun, are too distant for Neptune to have affected them. They orbit in a realm untouched by planetary perturbations. They are windows to the solar system's formation, clues to forces that shaped our cosmic neighborhood billions of years ago. Act 6. The Unexpected Discoveries. A second Kuiper Belt? Recent findings from NASA's New Horizons reveal a previously unknown population of Kuiper Belt objects stretching out to almost 90 times farther from the Sun as Earth. The study detected 263 new objects, including 11 situated between 70 and 90 astronomical units from the Sun, much farther than the traditionally observed range of 30 to 55 astronomical units. This discovery was unexpected. Theoretical models predicted the Kuiper Belt should end around 50 astronomical units, yet observations from the Subaru telescope and New Horizons found a significant population extending far beyond this boundary. One implication is that the Kuiper Belt may extend farther than formerly believed, or that there is a second Kuiper Belt beyond the one discovered in the 1990s. If confirmed, this would mean the disk of material from which our solar system formed was much larger than previously thought, perhaps more similar to the debris disks seen around other young stars.
The mystery of binary and triple systems. Many Kuiper Belt objects are not solitary. They orbit in pairs, binary systems, where 2 objects circle each other, bound by gravity. Pluto and Charon form the most famous binary, but dozens of others exist throughout the Kuiper Belt.
New research suggests that some Kuiper Belt systems previously identified as binaries may actually contain a third member, so close to one of the companions that it can only be identified by observing the system's orbital dynamics. This supports the streaming instability hypothesis for Kuiper Belt formation, which proposes they originated as triple systems through gravitational collapse. This challenges traditional models. If many Kuiper Belt objects formed as triples through collapse rather than through collisions, it implies a fundamentally different formation process than what occurred in the inner solar system. What the Kuiper Belt tells us. The Kuiper Belt is not just a collection of frozen rocks. It is a cosmic archive, a preserved record of the solar system's first 100 million years. In the inner solar system, planetary formation was violent. Collisions built the terrestrial planets, generating heat that melted rock and erased early history. But beyond Neptune, the process was different. Cold, gentle, preserved. Every Kuiper Belt object we study reveals details about the original cloud of gas and dust that gave birth to the sun and planets. The chemical compositions, the sizes, the orbits, all carry information about conditions 4.6 billion years ago. Understanding the Kuiper Belt helps us understand planetary formation not just here, but around other stars. Many young stars are surrounded by debris disks, rings of material similar to our Kuiper Belt. By studying our own, we glimpse how planetary systems evolve across the cosmos. Act 7. The Hunt for Planet 9. The evidence in the orbits. Following an analysis of the orbits of bodies in the Kuiper Belt, astronomers have proposed that an unseen planet, at least 25 times more massive than Pluto, might reside in the outer solar system. The evidence comes from the orbits of the most distant objects. Sedna, 2012 VP113, and several other extreme trans-Neptunian objects have orbital orientations that appear statistically clustered. Their orbits point in similar directions and share similar tilts. Random chance would produce orbits scattered in all directions, but these orbits are aligned. Something has organized them. The team analyzed over 150 Kuiper Belt objects that aren't gravitationally influenced by Neptune. At distances between 80 and 200 times the Earth-Sun distance, they found that their sample of Kuiper Belt objects formed a plane that was warped relative to that of the inner solar system. The most likely explanation, a distant planet, perhaps 5 to 10 times Earth's mass, orbiting hundreds of astronomical units from the Sun. This hypothetical world, sometimes called Planet 9, would gravitationally sculpt the orbits of smaller objects, creating the observed alignment. The search continues. Astronomers are actively searching for Planet 9. If it exists, it would be faint, perhaps magnitude 22 or dimmer, and moving very slowly against the background stars. Large sky surveys, including those conducted by the Vera Rubin Observatory currently under construction, may detect it in the coming years. Or perhaps Planet 9 doesn't exist. The orbital clustering might be a statistical fluke, or caused by something else entirely, perhaps the combined gravity of many smaller objects, or a passing star in the solar system's distant past. The question remains open, and the search continues. Closing. Beyond Neptune lies a realm of frozen worlds, each one a time capsule from the birth of our solar system. From Pluto's active glaciers to Arrokoth's pristine surface. From Eris in the scattered disk to Sedna in its lonely orbit. From the classical Kuiper Belt to the mysterious new population beyond 70 astronomical units. These worlds remind us that our solar system extends far beyond the familiar planets.
The sun's influence reaches outward for thousands of astronomical units, perhaps even light years into space, where the Oort cloud, a vast shell of icy comets, marks the true boundary of our cosmic home. We have only just begun to explore these frozen realms. New Horizons continues its journey outward, now over 60 astronomical units from the Sun, still transmitting data as it travels deeper into the Kuiper Belt. Future missions may follow. Perhaps one day, a spacecraft will visit Eris or Sedna or the mysterious objects that orbit in the solar system's twilight zone. These frozen worlds are the remnants of creation, icy fragments that never coalesced into planets, preserved across billions of years in the darkness beyond Neptune. They are the archives of our past, the clues to our origin, and they are waiting in the cold and the dark for us to discover their secrets.